In this video, we will go over 5 questions that review target 1A. We're going to start with question number 1, to question 2, 3, 4, and number 5. So let's get back to number 1. And before I go into number 1, I want to review some properties of exponents. Let's say I have 2x plus 3x, right? Well, if I have 2x's here plus 3 more here, I have 5x's, right? There's no exponents that change. Matter of fact, there's an invisible 1 here, and it stays the same. You just write it right there. Okay. Now, what if we had 2x times 2x? Okay. Well, now we have 2 times 2. That's going to be 4. X times x is going to be x squared. So, whenever we're multiplying a couple terms here, it looks like we add their exponents. And then the numbers in front of the two variables we multiply together. Okay, let's add to that. Let's say if we have 2x and we want to raise that to the third. Well, actually no, scratch that. Let's say we had 2x to the fourth power raised to the third power. Well, in this case, everything gets raised to the third power. So we're going to take 2, raise it to the third power, and then we have x to the fourth. We raise that to the third power, right? So now 2 to the third power is going to equal 8. And now whenever we have a power raised to another power, right, we do multiplication. So 4 times 3 is going to be 12. And that would be my final answer, okay? I'm going to refer back to this a couple times. So let's go back to question number 1. We have 3 terms here that we're multiplying together. So in this middle one right here, when we multiply terms together, it looks like we add their exponents, right? We add 1 plus 1, that gives me 2. So my bases are the same, so I could go ahead and add all these exponents together. So let's just say these 3 fractions, we want to add them all together. So I have 1/5 plus 3 more plus 4 more fifths. So how many total fifths do I have? That's going to be 8/5, right? Now don't forget that those are exponents, and the base was x. So it's going to be x to the 8/5 power. That's our answer. And keep in mind, the only reason we could do that is because we had the same base. We had x, x, x. Whenever we have the same base, you could add their exponents as long as we're multiplying. Question number 2 is actually like that problem that I did back here in number 1. This part right here. So I'm just going to do the same process. So it looks like I need to raise everything to the 1/2 power here. So if I evaluate 100 to the 1/2 power, I'm going to get 10. And that's actually the same thing as doing the square root of 100. Whenever you have anything raised to the 1/2 power, it's the same thing as taking the square root of it. So that's 10. And now I have n to the 14th power, and that's being raised to the 1/2 power. So back over to this example here, remember when we have a power raised to another power, we're going to multiply. So we're going to do 14 times 1/2. So 14 times 1/2 is going to give me 7. So then I'm left with an n to the 7th power. So I have 10 times n to the 7th power. Question number 3 has me multiplying together a bunch of terms. So I'm just going to rewrite this without parentheses. And you'll notice that, when we're multiplying and there's no addition or subtraction here, all we do is just multiply from left to right. So you have 6 times this, times this, times this, times this, and so on. To keep things organized, I'm going to rewrite everything next to their similar terms. So I write my numbers first, my m's second, and then my n's last. Now 6 times 2 times 7 is going to be 84. Then I multiply these two terms together, so when I have the same base, I could add their exponents because we have multiplication. So that's going to be m, and then 5/7 plus 2/7 gives me 7/7. I'm going to simplify that in a little bit. And same thing, I have the same base here, so I could add their exponents. So I have 1/3 plus 1/4. If I rewrite these with common denominators, I'll have 4/12 plus 3/12. If I add these two together, I have 7/12. So that's going to be my new exponent, and again I'll simplify this in a second. And if you were lost right here, I recommend just going back and figuring out how to find common denominators. If you don't remember that stuff, you could always use a calculator as well. That could work for the time being. But okay, let's go ahead and simplify all this. We have 84 times 7 over 7 is just 1, so I could write m to the first power. We'll keep that invisible for now, but there is a 1 there. And then n to the 7 over 12. Well, 7 over 12 is going to reduce. Actually, no, it won't. We'll keep 7 over 12 as is. So this is going to be my final answer. Sometimes you'll have to move this into radical form, but we won't worry about that for now. We'll just keep that as our answer. Question number 4. We have to figure out where the error is if there was one. So I'm bringing back my original warm-up problem that we started with. And when we add two terms here, it looks like we do not add their exponents and we add their coefficients, which would be 2 and 3. Coefficients are the numbers in front of the variables. So what Haley did here was keep the exponent, right, because we're adding, so that's good. And then there's an invisible 1 in front, there, and there. So 1 plus 1 is going to be 2. So it seems like she did it correctly. There's no errors. Hannah had the same thing, but it looks like she took 9 and then added a 9 to it to give us 18. That's going to be incorrect. Whenever we're adding terms, we do not do anything with their exponents. We don't add them, we just keep them the same. So this would be the correct answer, and that's what went wrong with Hannah's problem. Number 5 is asking us to determine if this is true right here. So one more time I'm going to bring back my warm-up problem, because it looks like we're multiplying two terms here. So what do we do with the exponents? Well, in the second one here we are multiplying two terms, and it looks like we added the exponents. So if we add 1/2 plus 1/2, that's going to give me 2/2, right? Which just simplifies to be 1. And there's no exponent up here that we can see. However, there is always going to be an invisible 1 if there's no number actually seen. So 1/2 plus 1/2 is 1. We have that there. So it looks like these two are equal sides. So this equation would be true. So to recap, everything really kind of stemmed off my warm-up problem, these 3 problems. And if you could remember those rules, you're going to be in good shape. But we had number 1 there. Moved on to question number 2. I did 3, 4, and 5.